This is AP Calculus AB Self-Check 3.3. We have 5 questions, which means we had 10 minutes to do the entire thing for AP pacing. And number 1, we're asked to find where we are either increasing or decreasing. So the definition of increasing or decreasing is where f prime is either greater than 0 or where f prime is less than 0. This is the increasing, this is the decreasing. Either way, we know by our definitions that f prime is what we're looking for, and we only have an f, therefore we need to take its derivative. So let's go ahead and find f prime of x. F prime of x will be equal to, again, the 3 comes down in front whenever we're dealing with our power house. So there's going to be 3x squared. The derivative of negative 12x is just negative 12, and the derivative of a negative 24 is 0, meaning ignore it when we take the derivative. So yes, you could set this f prime of x equal to 0, but usually what I like to do is I like to factor it a little bit more. So if you factor it a little bit more, you can say this is equal to, okay, what can we do? We can divide both sides by 3, both of these terms by 3. When the 3 is factored out, that leaves behind an x squared minus 4, and you might recognize that this is a difference of squares, a square and a minus sign. Minus sign means the difference. Both of these are squares. Difference of squares always factors as a conjugate pair, meaning that this fully factors as 3 times the quantity of x plus 2 times the quantity of x minus 2. You don't have to do it this way. There is another way to do this where you just set 3x squared minus 12 is equal to 0. Then you can add 12 to both sides, divide by 3, and then take the square root. As long as you remember that whenever you square it, you do the plus or minus, you'll also get the same answer. Either way, you'll set everything equal to 0, and that means that x will be equal to a negative 2, x will be equal to a positive 2, and those are the only possible values. You should get the same answer regardless. So you should get a negative 2 and a positive 2. Those are both critical values because we're setting our f prime is equal to 0. That is a definition of a critical value, at least half of the definition of the critical value. The other half of the definition is where f prime does not exist. We don't have a denominator, so that's not possible for this problem. Anyway, let's go ahead and find where we're positive and negative. And the quickest way to do that is to look at the right-hand behavior. The right-hand behavior will always look at the leading coefficient. The leading coefficient here, we don't see 1, so we assume it's 1. And that leading coefficient is positive. Therefore, the right-hand behavior is also positive. And to figure out quickly where these intervals are positive or negative, we can look at the factored form. I'm seeing that this factored form has a power of 1, a power of 1. Odd powers means that it will switch signs when we leapfrog over. So it will switch into a negative, and when we leapfrog over again, it will switch signs to a positive. So now that we have our sign chart all filled in, we can do the analysis. So where are we increasing or decreasing? We want to say it's decreasing between negative 2 and 2, decreasing between negative 2 and 2, increasing when we're less than 2, increasing when we're greater than 2. That's what we're saying over here. Therefore, the correct answer here is A. In number 2, we already have the derivative. Thank you. Okay, so it says the derivative, we already did it. There it is. And we're asked how many points will the graph have a maximum? All right, well, maximum means we need to switch from f prime to a positive, or from a positive to a negative. And that means we need to go ahead and look at a sign chart. So on that sign chart, we will have a 0 from this x is equal to 4. You'll have x to the power of 4 is equal to 0, and therefore x is equal to 0. You'll have x is equal to a positive 2, and x is equal to a negative 3. Again, a positive 2 will make this thing 0. A negative 3 will make that factor 0. And those are all of our critical values. Critical value, critical value, critical value. So I happen to notice that x to the power of 4 has a power that is even. Therefore, this 0 that came from our x to the power of 4 set equal to 0 will not change signs due to its even power. I'll put an X through that one to remind myself it will not change signs. I need to find where we're positive and negative for our intervals. I always like starting on the right-hand side by looking at the leading coefficient, which in this case is a positive. I don't see any number here, so I assume it's a positive 1. Therefore, it is a positive over here on the right-hand side. And when we leapfrog over each of these critical values, we will switch to a negative. I will not change signs due to the fact that we had an even power here, and then it will still stay a negative. And I leapfrog again over here, and we will have a positive. Therefore, we have all of our sign chart, and we can answer where do we have a maximum? Where do we change from a positive to a negative as we read from the left to the right? Well, a positive to a negative is right here, so we can go ahead and highlight. This is one of them. When we jump from a negative to a positive, that is a minimum, not a maximum. Therefore, none of those count. And again, this one doesn't count either because a negative to a negative doesn't even change signs. It's not even a relative extremum whatsoever. It's neither a maximum nor a minimum. Therefore, we only have 1, and that 1 happens at negative 3. All right, and number 3, we have that function, and we're asked, where's that function? Concave up. So you need to know the definition of f concave up. If you don't know it, it is where f double prime is greater than 0. You have to have those definitions memorized. So now that I have that definition, it tells me you're looking at f double prime, but I'm only given f. So my first step is to find f double prime. The intermediate step there is to first find f prime, and once we find f prime, we will take its derivative yet again to find f double prime. F prime is going to be, well, be careful, it's powerhouse. 3 comes down in front, 3 times 4 is 12, and then x goes down a power from 3 down to 2. So I'll say x to the power of 2, and then I'm going to subtract an x to the power of 4 derivative. 4 comes down in front, it's going to be 4x to the power of 3. And then I'll take the derivative yet again. When I take the derivative, 2 comes down in front, 2 times 12 is a 24, x goes down to the power of 1, and then I take the derivative of 4x to the power of 3, 3 comes down in front, 3 times 4 is a 12, so it's going to be minus 12x to the power of 2. So there is the second derivative, but I'm going to go a step further and factor out the greatest common factor. So what can I divide each of these by? I can divide each of them by an x, and I can divide each of them by a 12. Therefore, 12x is the greatest common factor, and when I factor out that 12x, what's left over is a 2. Again, you can see the x and x cross cancel. 24 divided by 12 is a 2, and these 12s cross cancel, and x squared divided by x is just x, so I'll have minus x in here. Setting each of these equal to 0 means I'll have x is equal to 0 and x is equal to a positive 2. Again, if I plug in a 2 here, you'll get a 0. So those are the different values that are on my sign chart as potential inflection point. I have a potential inflection point, a pip, at 0, and I have a potential inflection point, a pip, at positive 2. And from there, I'm going to re-look at the question. The question is asking where f double prime is greater than 0, so I need to look at positive and negative behaviors. I'm also noticing that in my fully factored form, both of these powers are not there, therefore the powers are 1, and 1 is an odd number, therefore it will switch signs every time I do my leapfrog over. What a very common mistake here is to think that the leading coefficient is 4, and therefore this right-hand side is positive. You would be incorrect because this is not in standard form. If I were to rewrite f of x in standard form, it would really look like this. F of x is equal to a negative x to the power of 4 plus 4x to the power of 3. Notice that this is written in standard form because it has a largest degree and then a smaller degree to the right. The largest degree should theoretically be the first value, but they hit it as a second value. The leading coefficient is actually this negative sign, meaning our right-hand behavior is actually a negative sign. And then it will switch signs to a positive and then switch signs to a negative. And now we have all the intervals. We're looking for intervals where it's concave up. It's concave up wherever it's positive between 0 and 2. So the correct answer here is between 0 and 2, which is option C. In question number 4, we're looking for a point of inflection. A point of inflection is where f double prime has a sign change. And my pen is really not working. Let me see if I can go ahead and try that again. Sign change. There we go. F double prime, and we only have y. We need to take the derivative not once, but twice. All right, taking the derivative once is going to be 15x to the power of 4 plus 40x to the power of 3, and then taking the derivative again is going to be 60x to the power of 3 plus 120x to the power of 2. While we do have the second derivative, I want to go a step further and factor this. So I'm going to look for the greatest common factor. I can divide both of these by a 60, and I can divide both of them by an x squared, So when I do that, I have a 60x squared that is being factored out, leaving behind, well, let's see here, the 60s are gone, x to the power of 3 divided by x to the power of 2 is just an x, and then 120 divided by 60 cross cancels down into a 2. All right, I have the fully factored form. I'll set this thing equal to 0. When I do that, I get x is equal to 0, and I get x is equal to a negative 2. And I'm also noticing that there's an even power here and an odd power here that will affect my sign chart when I'm doing my leapfrog method. Looking at our sign chart, I have a potential inflection point here at negative 2. Call that my pip. And another potential inflection point over here at 0. All right, I already know that we will have a sign change at our negative 2, which came from a factor that had an odd degree, but this 0 came from a factor that was an even degree. Therefore, this 0 will not change signs. I'll put an x through that 0 to remind me it will not change signs. Looking at the leading coefficient, this one is in standard form, so this is a positive 3. Therefore, I will have a positive behavior for my right hand end behavior. I will not change signs when I leapfrog over here, therefore it will stay a positive, but I will change signs when I leapfrog over here, and then I will have a negative. So I have all of my positive and negative intervals. Where do I have a point of inflection? I guess I didn't really even need to do those, did I? I just really needed to look at where we had even and odd degrees. This one had an odd degree. That was the only point of inflection. Therefore, -2 was our inflection point. We can go ahead and cross off the potential inflection point. It is indeed an inflection point. It changed signs from a negative to a positive at -2 and only -2. The correct answer is B. In number 5, we are trying to find where we are increasing or decreasing. Therefore, we are talking about where f prime is greater than 0, or where f prime is greater than 0, or where f prime is less than 0. Again, greater than 0 is where we're increasing. F prime less than 0 is where we are decreasing. Either way, we're talking about f prime. Therefore, we need to take its derivative, and near, oh my god, that's quotient rule. Quotient rule is low d high minus high d low all over low low. So I will write that down. That's our field map of what we're doing. We're doing low d high minus high d low all over low low, or low squared. Okay, so low is x, d high, the derivative of natural log of x is 1 over x, minus, okay, high is natural log of x, d low is just the derivative of x is 1, and then that's all going to be divided by low low, so it's all divided by x squared. So I can simplify this a wee bit, and I can say that the x times 1 over x is just 1, so I really have 1 minus natural log. In the numerator, the denominator is still x squared. So now that I have f prime, by the way, this is all f prime of x. Now that I have that, I'm going to set both the numerator and denominator equal to 0. Setting the denominator equal to 0 is where f prime does not exist. Setting the numerator equal to 0 is where f prime is equal to 0. So I can do that just in my head, right? So I can say when I set the denominator equal to 0, that's pretty straightforward. That's going to be 0. Setting x squared is equal to 0, you'll square root both sides, and you'll get x is equal to 0. Setting the numerator equal to 0 means I'll have to do 1 minus 1. The only way to make this thing a 1 is to plug in an e here. Natural log of e is equal to 1. Therefore, our second value is going to be e. Again, we can't plug in negative values over here on the left-hand side because I cannot plug in negative values to my natural log function. It's outside of the domain, so I can cross off that area. Nothing happens over here on the left, and I just need to figure out what happens over here on the right. And looking at the multiple choice answer, I kind of want to know both between 0 and e. Oh, why are these mentioning 1? Okay, they're mentioning 1 because they think that you forgot to take the derivative, which is a very common mistake, but you'll never have a value of 1 on our sign chart. So you, and you are wrong. It's not b, c, or d because it's mentioning 1 as if we forgot to take the derivative, because you do natural log of 1, which would give you a 0 for the top. It's between a and e, just on the fact that we're talking about e and 0. So let's go ahead and plug in some things over here. I know for a fact that if I plug in a number like, let's do a test point of 1. So if I do like a test point right here of 1, I can plug in 1. Well, to the bottom, it's always going to be positive, no matter what, because it's an even degree, right? So I can kind of ignore the denominator. But when I plug in a 1 up here, I'll get natural log of 1. The natural log of 1 is 0, and 1 minus 0 is positive. Therefore, I'll have a positive behavior here. It will be a negative behavior here, and the way that you can see that is by plugging in a number like e squared. When I plug in an e squared to this x, this e squared, the natural log and e cancel each other out. The 2 comes down in front, meaning this whole thing is just 2, and 1 minus 2 is a negative 1. Therefore, we get a negative behavior right here. So we just need to choose the right answer. Notice that everything to the right of e, everything greater than e is negative, which is a definition of f decreasing. The correct answer here is e. A is incorrect because say it's increasing when we're greater than 0, which is true at the very beginning, but then it turns into decreasing after we hit e, which this one forgot to mention. So we have all the answers there. Thanks for watching. I'll see you guys later.